In this video, we'll look at solving linear systems of equations in word problem format. In this example, a smoothie shop makes 3 different types of smoothies, each with differing amounts of pineapple, banana, and strawberries. The smoothie shop only has a certain amount of pineapple, banana, and strawberries available, and they want to know how many of each type of smoothie can they make if they want to use all of the available ingredients. Now, the first thing we want to do on any problem like this is to identify the variables. Remember that the variables are the things that we do not know. So generally, they're in the question part of the problem. And so we can see that here, how many of each type of smoothie can they make? And so that tells us what we don't know, how many of each type of smoothie. And so those will be our variables. So we want to know how many Hawaii smoothies we can make. We'll let that be X. The number of Costa Rica smoothies, we'll let that be Y. And lastly, the number of California smoothies, and we'll let that be Z. So now that we have those, the next thing we want to do is to write out our equations. Now, the easiest place to start with the equations is the right-hand side. We know that the left-hand side of a linear system of equations is going to be something x plus something y plus something z if it's a 3-variable equation, and then that will equal something. And so that equals something is what we want to start with. And so what we're looking for are the numbers in the problem that look like totals. And so in this case, 1,700 ounces of pineapple would be one of our totals. So we can start off with equals 1,700 ounces of pineapple. Now, because the right-hand side of the equation is in ounces of pineapple, everything on the left-hand side needs to be in ounces of pineapple as well. So if we look at our problem, we can see that the Hawaii smoothie requires 6 ounces of pineapple. So that's 6 ounces per Hawaii smoothie, which was X. The Costa Rica contains 3 ounces of pineapple. So that's 3 ounces per smoothie. And then the California requires 5 ounces. And so that's 5 ounces per smoothie. So 5 times Z. Next, we see that we have 2,350 ounces of banana, so we can start with that. And so, of course, everything to the left of that needs to be in ounces of banana. So the Hawaii is 6 ounces of banana, so 6x. Costa Rica, 8 ounces of banana, so plus 8y. And then the California, 4 ounces of banana, so that's plus 4z. Lastly, we have 1,950 ounces of strawberries. And of course, what goes on the left needs to be in ounces of strawberries as well. So 4 ounces of strawberries for each Hawaii smoothie. 5 ounces of strawberries for every Costa Rica smoothie, and 7 ounces of strawberries for each California smoothie. So this is our system of linear equations, and we can put this into our calculator and solve using the RREF function. So if we go to second matrix and then over to edit, I want to make this a 3x4 matrix, and I've already put all of the numbers in. So the first row of our matrix will be the coefficients for the pineapple equation. So 6x, 3y, 5z, and equals 1,700. The banana equation, 6x plus 8y plus 4z equals 2,350. And the strawberry equation, 4x plus 5y plus 7z equals 1,950. So now all we have to do is go to second matrix, over to math, and then go to RREF, and then select our matrix A. And what this will do is simplify that system of linear equations. And so what we end up with is x equals 125, y equals 150, and z equals 100. And so that tells us the number of Hawaii, the number of Costa Rica, and the number of California smoothies that the smoothie shop can make with the available amounts of pineapple, banana, and strawberries.